Alrighty, so today we are going to learn about ah there we go. Okay, today we're going to learn about coding and its essentials. So before I do that, I'm going to forgot to screen share for you to see it. Tell me when you can see my screen.
I can see it.
Okay, cool. So, just to get started right away. This is what the code in Unity looks like. It this is for a game I made for someone's birthday. It was this game. I'll show it up real quick. It was a Dragon Ball Z clone game, like a clicker game I made for my brother. So very simple, a bunch of clicking, nothing more to that. So I wanted to show that to show the comparison of what it looks like in the code. Um, it may seem like a lot, as you see. It could go on. This one goes on for 5,000 lines. And as an example I've shown before, one of my biggest games goes down to 27,000 lines to get a comparison of what code looks like. Now, I'm going to explain the fundamentals again of coding, just so everyone can have the basic idea and how it reflects on Unity. Uh, First thing we're going to talk about, I'm going to put it up, is variables. Variables are the main information storage of coding of any language. So basic variables you have, I want to make sure, is ints. We got ints, boolean, no, they'll do floats, booleans, strings, and arrays. Now, ints are anything numbers wise. We'll go 1, 2, 3, 4, 5, etc. Floats are anything number wise, but also in decimals are included. 1.2, 1, 5, 6.3, etc. Booleans are switches or true and false statements. That's all they are. True, false, nothing more. Strings are anything text wise. So anything that's stored between quotations. So literally, it could literally have nothing. It could literally have blah blah blah, and it can also store different variable numbers, such as oh, plus int name plus, and that int name would be something like I don't know, the health number. And int equals 0. And so, since this is, we'll actually do 4. And it would be health number. And so, because this equals 4, it looks in for the looks for the int called health number, and it projects it as 4 as a text bar. Then we got arrays, which are a list of any one of these kinds of variables. Like for instance, enemy health int, and then it's signified by these brackets. So inside these brackets, you would put a number like 5. In this example, let's just say you have a bunch of enemies and you want to dictate how much health they have based upon the list of them. You put it all in an array. So to give an example of what they look like, we could look at in Unity here. You have the ints I put, you have the floats I put, and then you have strings I put, booleans, and in Unity you have to each array even though it's basically a different kind of variable, they do it to its. You write it based upon its other variable classification that you want to attach it to, such as strings. Put their brackets here to make it an array. Floats, you would put brackets as well, so on and so on. So those are the variables. Now we got main components, which are called functions. Functions are things that happen, things that make the game run. Um, there are four main functions. Actually, no, three. We're gonna start with three. Three main functions that every single coding software has, at least from what I understand. You have the start function. The start function is a function that happens the moment the code is entered into the game. Such as if, let's look at Unity. You have a piece of code right here. Since this code, I call it the engine, is already on the in the field the moment the game starts, whatever code is attached to this, which is called the engine, which engine script, it goes in here and it finds the start script and it immediately plays what's in here. So that's what the start function is for. Then you have the update. The update is a listener to where every single frame it looks inside here to see what needs to be updated, whatever you put in there. Then you have what's called get functions. What get functions are, first I would have to explain something about variables to explain get functions. Variables have about three different classifications. There's public, which means that any script outside of the script that it's in can reference this. Like for instance, let's just say you have the main character has a certain amount of health and it's in the form of an int. You have an enemy, which is another script, wants to reference how much health the first script has. So they would be able to reference their health if it's a public int. However, if you want an int or a variable that can't be changed by any other script, you would classify it as protected instead. This makes it so no other script can change the variable inside it. However, what if you want to keep it protected, but you still want to be able to reference it? That's what get functions are. And I believe I have some down here. Yep. So inside here, these are get functions. You would get a variable, the specific stat of the variable, and inside the functions you would be returning the variable information you want. All it's doing is returning giving whatever the caller whatever the information is that's trying to reference. So those are the main three. Others that get used but are not in all of them are colliders. Colliders are anything that require a hitbox for things such as clicking on a mouse, or in like a platformers or something, when something collides with the main character collides with an enemy. It needs a collider function to dictate what happens when something touches something. Then another kind of function is input functions, and those are clicking a clicking a button on the keyboard, clicking a button on the on a on the mouse, clicking a button on the controller. So again, these two down here aren't necessarily in every bit of code. Um, Colliders are way more common than inputs, but these two are still pretty common, and you want to be able to utilize them. Um, Now we are going to, with that over with, we're going to talk about the three main important things to keep track of with coding. Uh, what what makes a really good coder? So let's just put important rules. So we got logic. We got the organization. Then we got compartmentalizing. I hope I spelled that right. So the logic is pretty simple. Just this happens and then this happens, which oops, which makes this happen. Oops. Which makes me wish I had a whiteboard, but nonetheless we're striving onward. So it's just simple logic. When a button is pressed, this happens, which makes this happen. Let's say in Super Mario World you had, or hell, just with this game that I showed, you press a button, and when that button is pressed, oh, let's hope I can find it. Would I be able to find it? I'll actually use one of the menu items. Actually, no, this is too long. Way too long. Anyways, it's basically understanding the logic of how you input your code. How you input your code. You want a result. Uh, for instance, Super Mario Brothers. You want Mario to jump. How do you get to the point to where you make Mario jump? You would add a. You would you'd have to use your tools of programming to make that work. Which is, in this case, you would have an input function. Input function, press a button, and inside that input function, it shows, it puts into code to how, what Mario does, everything that involves pressing a button, and the result is Mario jumping. Now, organizing. This is the part where programming doesn't really care how you do it, the actual program itself. The logic is obviously really important for the coding, because if it doesn't have the right logic, such as speaking a language, if you don't say the right words, the sentence doesn't make sense. Same thing with programming. You need to speak the exact right words to the program, or else it's not going to recognize it. Organization, programming does not care how you put things on the programming. Like, all this code, it could be rearranged in any order it wants. All these functions, I mean, it can be rearranged in any order it wants to. It doesn't matter as long as the function's there. But you need organization for your own sanity and everyone else's sanity, because if you don't organize it for yourself, and organization is not just where you place it, but how you name it as well. For instance, uh, what I created in this file was called an engine, and some people do this, some people don't. But the way I do a lot of code is I put everything that's universal in an engine file in order to store and relay data that is going to be universally used and referenced. The way I did it in this is I would categorize it by what it's by sections. For instance, this is all the UI code. Like anything that involves the UI, I put it under this banner right here. For anything that's equipment code, I put it under this banner. So on and so forth. I would do it with every other script. I would also section off each variable by its public versions and its private version, it is protected version, and by variable classification. Like, excuse me. Um, this actually should all be below this public string in order to make it organized a little better. But nonetheless, you want to do it so that if you come back to this 5 months later, you can understand how your code works. You can look at it and say, "Oh, I know what this says," because, for instance, this protected boolean, I know what this is. This is the sound effects boolean. It tells whether the sound effects are on or off, and all throughout this code, it has a conditional branch to say if sound effects is true or not. Then it'll play the sound effects. Same thing with music, voices, tips, and new game. Let me just pick a random one. Find a page. That would be most likely the one that in the game you click a button and it tells which page of the fighters you're on. There's 2 pages so far, and this one will probably tell you. See, names are incredibly important. Most likely next quarter we may have the possibility of having more than one coder, and we'll be using try to be using a software to people where coders can kind of share source source code, as in they'll be able to all work on, like, open up the files from a base like a base program. Um, this would be the first time I'll be organizing that myself instead of just utilizing it. So we'll see how that goes. Nonetheless, that's the extreme importance of organization. Next, we got compartmentalizing. Now, what the hell is that? It's about squishing down the code as much as you can, because you can say any code any way you want. I'll give a stupid example, but it's the most common example. Let's just say I'm actually gonna write it in code. Let's just say let's look at a random variable so we can make it look. If gravity is greater than or equal to 10. I'm gonna make it so it's focused it there. So, no, let's just say 5. We'll do 1 through 10. And, like, that's pretty short. Like, all you had to do is that. That in order to, and the result, let's just say the result you want to get is number through 1 through 10, and then you want to say whether it's greater than or equal to 5. Like, that's easy, simple, right there. However, you could do this an even longer way. If gravity equal to 1, no, and then copy the code, bop, 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 and then change every single one of them. 2, 3, 4, not 41, 5, 6, 7, 8, 9, and we'll make this 10. Now, this will say the same exact thing. The code will look through this, and it won't care which one you choose to do. As long as it's written the right way, code doesn't care. However, the code does care if you decide to choose this method instead of the other method, to where it's just asking for the greater than or equal to 5. For one simple reason. This is only about 1, 2, 3, 4, 5 lines long. This is 30 lines long. What do lines mean? What am I talking about? Lines are the they're basically the processing sentences for the program. The code has to go through each individual line to check if there's code there, and that takes processing power. And with and a code only has so much processing power. Your computer does, but your code also does too. Your code can only take so much. So if you decide to gobble it up with insufficient, which is make it zeros in this, insufficient coding that is gonna take up a crap ton of power for no good reason, it will create, it will like there will be not enough buffer room for just in case a game requires a lot of processing power, because unfortunately, when it comes to coding and making games, there is no foolproof way to make it so it never gets to this top of the line. Uh, there's always going to be a part or a way to break it to where it overloads it. However, your goal as a programmer is to make it so there's as much buffer as possible before it reaches the top. And doing code will this way instead of that way will not get you those results. It'll add a crap ton of unnecessary code, unnecessary processing. This all this takes time. It takes time and it um takes practice, because you're gonna have one way of doing things, one way of learning something, and you're going to start just for writing code just for the sake of trying to make it work. And that's okay for small games, just to start out with, because with tiny games, most likely you're not gonna get to the point to where it's gonna break. It's gonna overload the system. Like a 5 to 30 minute game, probably not. However, you're gonna make longer and longer and longer games, and then code looks like this. Code look like a nightmarish hellscape of of logic and words and just this nightmare. And I will tell you, this code right here is a nightmare that I didn't need it to. It didn't need to be this way. Most of this code happens in the update function, and what that means is, 50% of all of this is going through each frame, and that's a lot to put on the system. And unfortunately, what happened with this specific game is what's called an object limitation, like a object overload, to where the way it worked in Flash is when you shot, like for instance, when you shot a fireball, it would store in the game, oh, there is a fireball object, and it would send it off screen, and it would supposedly delete it. But the way Flash worked is, if any bit of the code anywhere in the game exists in some reference one way or another, that's called it keeps it, and I believe that's what it's called, a leak, memory leak, to where it keeps that tiny bit of code, which is like, I don't know, a couple bytes, and that's barely anything. But when you have a bunch of tiny little bytes, it stores up over and over and over and over and over until it becomes way too much. And that's what happened. When you're coding, especially for a small game, you don't realize are going to do when things are going to do that. When uh if a memory leak is going to happen, until usually it's way too late. I believe I went through everything. That went a lot faster than I thought it would. Alright. Well, I'm gonna go ahead and end this recording. And hopefully this has been very useful for everybody.